Good afternoon, everybody. We apologize for the technical difficulty, which caused a little delay, but nevertheless, we are very happy that you're all back to us, and we welcome you to our webinar, Solutions for Small Municipal Sewage Treatment Plants, STPs. The goal of this webinar is supporting you in the pursuit of expanding your knowledge for the best available technologies on the market for small municipal sewage treatment plants. In this webinar, we are delighted to present you our references for small STPs, our standardized solutions developed by Veolia, which focus on the challenges in the Middle East, moving back biofilm reactor, our MBBR pack, and rotating biological contactor. First, I would like to inform you that your microphones are on mute, as you might have noticed. In the event you would have some questions during this presentation, please put these ones into the sections as illustrated, and we will be happy to answer them afterwards. We will send you, along with the webinar presentations, the brochures of our introduced technologies and solutions. Additionally, there will be a short survey to understand your interests and priorities for our next webinars. Our speakers today are from our local business units in UAE, Saudi Arabia, and France. Today, Mr. Stefan, Mr. Ashok, Mr. Dante, Mr. Mohammed, and Mr. Golden will share with you their expertise and give you insight of their many years of experience in wastewater treatment applications. We are happy to share that our international network of experts and local presence in the whole Middle East enables us to better understand your needs and offer you the state-of-the-art water and wastewater treatment solutions. At Veolia, we provide a complete range of services required to design, build, maintain, and upgrade water and wastewater treatment facilities for industrial clients and public authorities. In this webinar, we will explain the basics of small sewage treatment plants, the available technologies with their advantages and disadvantages. And afterwards, we will introduce the best available solutions for small STPs, our standardized package for moving back biofilm reactor and RBC. In this part, we will explain the technical differentiation, added value, and present case studies. So let's get started with Mr. Ashok.
Thanks, Nargis. Hello to everyone. I'm Ashok Taylor, wastewater expert with VWT Gulf, and I will discuss about what is small or package STPs, key criteria in the selection of small STPs for one's need, available technologies in the market, and its pros and cons. So here we refer to STPs for the population equivalent of 5,000 or less, where the wastewater flow is less than 1,200 meter cube per day. The small STPs are required by small communities, which is not connected to sewer network, and many it is required by shopping malls, temporary camps, schools, hotels and resorts, and so on. These small STPs are compact, prefabricated, easy to assemble at site, requires minimal civil interventions, and they are easy to operate. Well, in terms of treatment performance, these STPs are designed to treat typical wastewater quality, bearing COD from 600 to 700 milligram per liter, BOD and TSS of 300 milligram per liter, TKN of around say 60 milligram per liter, as this quality which is normally observed in the Middle East. The effluent quality matches with the discharge regulation observed in the Middle East, which varies from one country to another, but mostly these small STPs can meet the irrigation quality requirement, which is required for nitrification or total nitrogen removal. Now we will see what are the key criteria in the selection of correct package or small STPs. You can see in this slide, there are 4 criteria which is revolving around the core criteria of CAPEX and OPEX. The key criteria in the selection of the package STP technology is its operability. The 2 criteria you see in the slide on your right. The package A small STP should require minimum operation and maintenance intervention, and it should be easy to operate. Further, it requires low process monitoring and testing. This is quite essential for small STPs as it cannot have skill set required for the round clock operations and process monitoring as normally observed with the big plants. The other criteria in the selection process is the small STP should be able to handle very well the variations in the flow and pollution load, which is normally observed with the small community sewer networks. Further, the small STP should have minimal footprint and it should be reliable in operations and process performance. The slide shows all these 4 key criteria in a decision-making process, and that ultimately governed by CapEx and OpEx. Now let us review the available small STP technologies in the market, which are mainly based on the based on the activated sludge process. As you can see in this slide, the activated sludge process is consisted of 2 subcategories: suspended growth process reactor and attached growth process reactor. In suspended growth reactors, the biomass remains in the form of suspended flocks by the mixing action of the aerator. Whereas in the attached growth process, biomass is either affixed to a fixed medium inside the reactor, which is stationary, or biomass is attached to a carrier medium, which is moving within the reactor. Here, mostly the mixing and aeration is effected again by an aerator. The suspended growth process, like conventional activated sludge reactor, SBR, MBR, these are normally technology applied for small package STPs in the market. In attached growth process, normally available technologies in the markets are submerged aerated filters, it's called SAF reactors, RBCs, rotating biological contactors, and MBBRs, which is moving bed bioreactors. Now we will briefly review the advantages and disadvantages of these available technologies. So this slide shows the suspended growth technologies available in the market. The suspended growth reactors in common, they have advantages of average resilience to the process upsets. So as I mentioned to you that it should be able to handle the fluctuations in flow and load very well. So this shows average resilience to these fluctuations. There are common disadvantages associated with the suspended growth reactors, which is it requires close monitoring because it requires constant adjustment to the MLSS and the sludge wasting. So it requires testing, more testing and monitoring. And this technology is quite prone to bulking episodes if the process is provided in NDN mode, that is nitrification, denitrification mode, or in case of toxic episodes. In general, the conventional activated sludge reactors, they are simple process, but among all suspended technology available, they are having the largest footprint. SBR reactors, they are relatively small footprint compared to conventional activated sludge process. However, it has got disadvantage because it's a batch process and it requires upstream or downstream equalization. Further, it operates in cyclic mode, and that's how it requires PLC programming and its complex automation. So it requires skilled operation and maintenance. Similarly, MBR, which requires efficient fine screening down to 2 mm. And same, since the membrane process is involved, it's a very complex automation involved over there, requiring skilled operation. However, this is the having the smallest footprint in suspended growth process, and it doesn't require tertiary treatment process. Let's go to the next slide. This slide shows the available attached growth technology based solution in the market. So attached growth reactors commonly have very high resilience to process upsets. So mostly all attached growth process can handle very well the fluctuations in flow and load. They are relatively having small footprint, and they are not prone to the sludge bulking. So, where the other important aspects, all the attached growth process requires fine straining down to 6 mn. Let's look at the MBBR, the benefits of MBBR. It's having the smallest footprint comparable to MBR. It offers the flexibility in choice of selection of downstream solid liquid separation unit, and it requires minimal operation and maintenance and process monitoring. However, in case the wastewater has got suppose high TSS, it requires preliminary settling step. The rotating biological contactors. For small units, this requires the minimal operation and maintenance and process monitoring. They are very quick and easy to install. And like other technologies available, it doesn't provide noise or odor. Well, the quality comes out from the RBC is such that it requires a good tertiary filtration process downstream. Submerged aerated filters, again being attached growth process, and it's a type of filter. It offers the flexibility in choice of solid liquid separation. However, the submerged aerated filter based package STPs are quite prone to clogging of the media. And due to the clogging of the media, several times it causes issues with the inadequate mixing of the wastewater, its distribution, and short circuiting at the bottom of the fixed media. So we have briefly reviewed available technologies in the market, that its pros and cons. So I will now hand over to my colleague Stefan Loss to take us further into the presentation. Stefan.
Thank you, Ashok. I will now summarize the advantage and disadvantages that we have just seen in terms of footprint, CapEx, OpEx, and operability for the different technologies. Let's start with the footprint. Footprint is not only important because of the required space, but because it has a direct impact on the CapEx. Small STPs usually consist of steel tanks, which are one of the main costs. So a small footprint will also reduce the CapEx. If we look at the different technologies, we see that the activated sludge is the most area extensive technology. The most compact one will be MBBR, RBCs, and MBR, which are about 1/3 of the activated sludge plant footprint. Other technologies such as SBR and SAF are in between. If we now look at the CapEx, we can see the most expensive technology is usually the MBR because of the membranes and auxiliary equipment required, while the most competitive technology would be RBC for the low end of the flow range and MBBR. Let's now look at the OpEx. The specificity of small plants is that staff costs represent a large portion of their OpEx compared to bigger plants. Operability therefore play a key role, as complex plants will need more specialized operators with higher salary. If we look at the different technology, it's not a surprise to see that MBR is the most expensive to operate, as it combines high electrical and chemical consumption with a complex technology. SBR is in the mid-range, as it requires specialized operator due to the complex regulation of the plant. The lowest OpEx will be for MBBR and RBC, especially for RBC, as the electrical consumption is very low, as there is no blower for aeration. Finally, if we look at the operability, we see that MBR and SBR are the most complex to operate, as they combine the complex automation and the disadvantages of suspended growth process monitoring requirement. The most operator-friendly technology would be MBBR and RBCs. As for this fixed biomass process, it required no process adjustment and almost no regulation. Once it's on, you can just leave it on its own. So as a summary, we can see that the most effective technologies for small STPs are RBC for the lower flow range and MBBR. This is why Veolia has selected MBBR and RBCs as our key solution for small STPs, and we are now going to review them in more detail in the next part of our webinar. And now, let's look at some references in the region. Next slide. Usually, clients have some common challenges. They are far from the existing sewerage network, and they cannot be connected at a reasonable cost, and the available space is limited or expensive. As you see, the main application we found in the region are for hotels, resorts, small compounds, labor camp, or industrial zones. And now we'll look in more detail at one of our references. Next slide. Lequia Sports Stadium, which has been constructed for Qatar Olympic Committee. It's a 2 times 450 cubic meter per day plant, treating municipal sewage, and the treated water is used for irrigation water. The solution proposed is MBBR, lamella settler, and disc filter. And so what were the client's needs? This STP is treating the sewage of a sport zone comprising different sport facilities, a stadium, and some hotels. It needed a dedicated STP as this area was not connected to the sewerage network. The client had 3 main concerns, which are the space, the visual impact as the plant is next to the new playgrounds, and odor. The solution proposed was consisting of MBBR and disc filter, which are both compact and have minimum visual impact. If we look at the process, after pumping station and core screen, we have an equalization tank, followed by fine screen, then MBBR reactors, followed by lamella settler, disc filter for tertiary filtration, and a chlorine contact tank for disinfection. The raw water quality is typical of a sewage treatment plant in the region, slightly higher than the usual one with COD up to 900 ppm. And treated water is typical of irrigation water also in the region with BOD and TSS of less than 10 ppm. So we will now present the solution we have developed for small STPs based on this technology, and Dante will start with the MBBR pack.
Thank you, Stefan. Good morning, good afternoon, everyone. So in order to introduce you the Middle East MBBR pack, I would like to start with a small history and motivation. So in other words, why and how we came to the point to develop something specifically to the region. So I decided to present 3 main axes of reason, let's say. The first one, global expertise and local experience. So first of all, as my colleague said before, MBBR is a technology developed by our sister company, Anox 30 years ago, and it is still being improved. We have a lot of experts and R&D department. It's one of the proven and most successful technology of Veolia portfolio. So we are quite confident about this technology, and references are proving it. On the other hand, this MBBR technology has been introduced in the Middle East 10 years ago, and now we have more than 200 references in the region, from various capacity going from 100 to more than 10,000 cubic meters per day. So this experience specifically to the region brings us confidence, of course, on the process design, but not only, also in operation experience, which is facing specific challenge, local challenge. The first one you can imagine is the high temperature of the water, which is very rare in the Northern Europe. So it is important that we are having a feedback from the operation of operating a plant locally. We are also dealing with local manufacturing, with various operator skills, and of course plants located in remote areas. So all this experience brings us really confidence in the design and operation of this plant, of this technology in the region. The second point is the market needs. Statistically, we are receiving many inquiries yearly, but 70% or more of the received inquiry are related to a small capacity STP, from 100 to 1,000 cubic meters per day. And that's logic because it's not every day that you build a huge plant. Now, on the other hand, these small STP usually are fast-tracked because they are for temporary labor camps, for new development area, for resort, hotels, university campus, etc. And also they are limited footprint. And finally, they have to also cope with various regulations, government, public authorities, industrial area, semi-private, etc. And it has to cope also with different discharge requirements, some for restricted, non-restricted irrigation, some clients will ask it for reuse, or even discharge to the sea. And the last point is, of course, the challenges we are facing, because without the standard, that means that we have to redesign, to rework the design each and every time we do small STPs, which is, of course, increasing time and cost. And finally, we are facing a tough competition, definitely, through technologies, but also with other companies. And that is why we came to the point that there is a match between the needs and our capabilities to produce a MBBR pack specific to the Middle East. And that is why we have decided to go, first of all, with two models, which I'm going to describe a little bit later, C and CN, which is for different discharge requirements, a full range of flow from 100 to 1,000 to cope with different requirements, which is pre-assembled, skid-mounted, of course, compact design, and then definitely operator-friendly automatic operation. So now let me just go into detail with the first model we have developed, the C. So we call it MBBR C series. Okay, so as you can see here in this short flow diagram, it is composed by a pre-screening, okay, and then followed by two biological MBBR tanks. The first one is called C tank because it is dealing with carbon removal, so mainly BOD and COD. The next tank is called N tank or NIT tank because here the nitrification will occur and the ammonia treatment will be done. After that, the water will go to the flocculation tank and lamellar clarifier as a secondary clarifier and extracting the sludge. And then as a tertiary, we propose our drum filter and then chlorination for disinfection. As you can see, we produce 4 models, C100 with the flow can deal between 100 and 150, C250 from 250 to 320, 500 which is dealing from 500 to 650 cubic meter per day, and the biggest one, the 1000, which is dealing from 1000 to 1250. The reason why we propose those ranges is again as per the statistic and previous inquiry that it is the most commonly asked capacity. But also by having these 4 ranges, we are confident that we can cover most of the requirement by combining by multiple lane, combining those units. In terms of parameters, so we took the typical sewage, municipal sewage inlet, as you can see from BOD, COD, TSS, TKN, and ammonia. And for the outlet, we are reaching BOD less than 10, TSS less than 10, COD less than 100, TKN, so total nitrogen less than 5, and ammonia nitrogen less than 1. So this unit is suitable for most irrigation and reuse regulation. So now let us see a little bit more in detail how it looks like in the next slide. So here are the isometric view or the model view for the C series. As you can see, we have the 4 models there with an indication of the dimension. You can see the 2 tanks and the drum filter on the elevated area. So here, as you can see, it is very compact, skid mounted and pre-assembled. My colleague later on will go into detail of one of the units. So now just it is an overview of how it looks like. So as you can see, it is very compact. But also we have decided to develop a second series, which is the CN. Why? Because in some cases, and in Saudi Arabia mainly, but not only, we need to cope with even more stringent requirements, where we will be asked to have complete nitrogen removal. So complete nitrogen removal means that we need to do the denitrification. So that's why you can see in the scheme that the scheme is done with a pre-denit tank. Okay, so we have one additional tank before the C tank. Okay, and for those who are familiar with the sewage treatment plant, you know it is typical. We have a pre-denit tank, C again for the BOD, NIT for the nitrification, and then an IR, which is diminutive of internal recirculation, because we are recirculating internally the nitrate, okay, which has been produced by nitrification into the pre-denit to do the denitrification. And the rest is the same, lamellar clarifier with flocculant and drum filter with chlorination. So I will not repeat again for the flow, because it is the same as you can see, and we follow the same philosophy than the C range, with the range from 100 to 1000. And then if you see the parameters, it is the same, but we have one additional guarantee, which is the nitrogen, the nitrate nitrogen, less than 10. So that is why this unit is suitable for even more stringent requirements, such as unrestricted irrigation or sea discharge in some country, like in Saudi Arabia. So now let us see how it looks like. So this is the CN series. So the same concept with skid-mounted, pre-assembled, and compact design, but a little bit bigger, of course, because we have additional tanks. But as you can see, the philosophy is the same from the 100 to 1000. So as you can see, 500 and 1000 has been done in two blocks because of it's a bit larger capacity. So we are following the same philosophy to produce something very compact and skid-mounted. Now I will leave the room to my colleague Mohamed Karim, who will present you a very nice animation to go through one of the standards. Thank you.
Thank you, Mr. Dante, and hello for everyone. As mentioned by my colleague, that we have developed two MBBR packs, carbon removal and carbon nitrogen removal. Here in this part, we'll go together through carbon removal, BOD, COD via 3D modeling animation video. As you see, we have 4 MBBR packages with different capacities and different dimensions. The capacities are selected based on the market requirement. We have 100, 250, 500, and 1000. In this scene, we have selected one standard unit with capacity of 500 to show you how it's easy and practical to move it by truck and handling it at site. It's just a plug and play design, easy for installation. Here I would like to highlight the advantage of our MBBR standard, relating firstly the saving in footprint and of course the reduction in capex value. As you see, the concrete pad next to our standard is remarkably big. This is the area required for conventional STP for the same capacity of 500. It's almost 6 times bigger than our standard. Let's have a quick tour via process flow diagram using C500 package, along with odor control and dewatering system. From equalization tank, the sewage is pumped out by submersible pump to static fine screen and then to MBBR tank where carbon gets removed. Then sewage passed to the second MBBR tank where nitrification occurred. Here we use air blower to give oxygen to bacteria and keep media moving for the process to take place. We use an oxcaldness media type with high efficiency. The flow from MBBR tank flows by gravity to multi-flow flocculation tank. The water then flows by gravity to the settler. The sludge settles at the bottom of hopper and the clear effluent water shall overflow to drum filter. Here we use our technology, the drum filter Hydrotech. The drum filter is a mechanical and self-cleaning unit that offers a large filter area on a small footprint. It's superior if compared drum filter with multimedia filter. The drum filter has footprint 3 to 4 times less than media filter. It has 10% less power consumption. The drum filter has low installation and operation cost. Only 3% of influent water required for backwash by using drum filter. The filtered water flows by gravity to chlorine contact tank and then pumped out to water storage tank. The sludge in the bottom of settler shall be pumped out to sludge holding tank and then to dewatering system. We are considering OCU and dewatering as options in our standard. It depends on the requirement. All our packages are equipped with very sophisticated and useful digital tool called Aquavista. It's a real-time remote monitoring which enables remote working, avoiding emergency call-out, and reducing risk of downtime by early warning and predictive algorithms. With Aquavista, you can access to plant data from any location and any device. Aquavista also extends the client support by giving on-demand troubleshooting and support by our expert. In the last part, our colleague Mr. Golven, General Manager of PMT from Veolia Water Technology France, will present you our interesting technology, the EcoDisc. Thank you.
Thank you, Mohamed. So on the EcoDisc part, I want to mention first that the RBC products are manufactured and distributed for the Veolia Group by a subsidiary called PMT, with manufacturing capacity in France and in Germany. The acquisition by Veolia of its own RBC brand was done to ensure that we can deliver to our clients the best quality product and that we keep bringing innovations to this classic technology. The RBC units are commercialized under the name EcoDisc. Today, we will present you the EcoDisc Solar, and the latest addition to our range, the EcoSim. And now, here is a short video presenting the EcoDisc in its EcoDisc filter version, in which a drum filter is coupled to the biodisc and packaged in a single standard unit. This is typically a Veolia innovation. So same as the MBBR pack, the EcoDisc is a true plug-and-play product with minimal civil work required, as it is simply laid and spitted on the concrete slab. The EcoDisc is integrated into the plant after a pretreatment to remove the coarse particles. In this video, it's a primary settler, but the pretreatment can be as simple as a screen. So the effluent flow into the EcoDisc unit by gravity. Here, this EcoDisc filter is composed of 4 compartments, the motor compartment on the left, 2 blocks of discs for the aerobic treatment, and a drum filter on the right for secondary clarification. Once the bacteria start to form on the disc, they have access to oxygen when they are in the air and to the pollution and nutrients when they are under the water. Once the bacteria die, they are carried with the treated water to the clarification stage. So here, a drum filter. The treated water transporting the sludge enters the drum filter, and the sludge is filtered from the inside out by the filtering panel. The panels are automatically backwashed with the integrated backwash system, which uses the clear water produced by the unit and does not require any external industrial water connection. So the sludge retained on the filtering panels is backwashed into a gutter and is then extracted by gravity from the unit. In parallel, the clean water can be rejected directly into the environment or sent to a tertiary disinfection stage for reuse application. The unit that has been presented in this video has a capacity to fully treat the effluent from about 400 people equivalent in the Middle East. So let's look a little bit more closely at the advantages of the EcoDisc technology. It is a chemical-free biological treatment, and because the energy for the aeration is provided by a single fixed-speed motor, its energy consumption is extremely low. plus the quality of the motor reducers and rotating parts that we use ensures a very low level of noise, below 60 decibels. The retention times are kept short, and as it is an aerated process, there are no odor issues. This is so true that most of our references in the Middle East are for units that are installed directly in the building basement. The simplicity of its operation means that it is most of the time operated by a general maintenance technician, while we guarantee quality performance on the long term. Next slide, please. Here, I would like to present briefly how we differentiate from our competitors. As our competitors, we provide a simple product which requires no chemicals. However, thanks to our high-quality motors, our energy consumptions are even lower. But what really makes the difference and has made us so successful in the Middle East is the quality of the components that we use, coupled with the capacity to offer expert services by a local Veolia team. Our clients trust that their EcoDisc units will run trouble-free for many years. And to even guarantee that smooth operation further, all our units are now Aquavista enabled, which means that they can be connected to the Veolia Group secure digital platform. And now, let me introduce our exclusive EcoDisc Solar. The EcoDisc Solar was developed for our clients that do not have a simple access to a steady energy grid because, for example, they are in an isolated site. The EcoDisc Solar already integrates the battery and the converter to power it directly from the solar panels. Plus, it can also be used to produce current and power equipment on the pretreatment stage or on the sludge line. With our solar power EcoDisc, some of our clients are saving tens of thousands of dollars every year in fuel for their generators. Next slide is a presentation of a second innovation, the EcoSim, which is also the latest addition to our product range. EcoSim takes the best of both MBBR and RBC technologies to deliver high-quality water treatment with the capacity of an MBBR and the simplicity and robustness of an EcoDisc. Thanks to the integration of Anox Galvnest MBBR chips inside the rotating drum, we can reduce the footprint of the wastewater treatment by 3 for communities between 500 and 1,000 people equivalent. Besides, a single EcoSim treatment capacity can be very simply extended to meet the treatment needs of a growing community simply by adding more media. And now, I would like to present you TNT Life. As mentioned, all our units are manufactured ready to be connected to allow a remote follow-up of the critical parameters: the motor, the greasing, the roller bearing temperatures, the shaft rotation. The connection to the Aquavista platform means full access to our service teams, which can access remotely and instantly the parameters of the machine and assess the behavior and the condition of the EcoDisc or the EcoSim to guarantee the longest possible life of the investment. Next slide, please. This is a very quick overview of our installed base in the Middle East. We have lots of reference already, and most of them are in Saudi, where the technology is very well known, with more than 200 units today in operation. Our clients come mainly from the tertiary sector, but we have also supported some industrial clients in the region with a reliable and easy to operate water treatment alternative. And now I want to show you a few pictures of examples of those projects that make us proud in the region. Typically high-end clients, which are the heart of our development, thanks to their demand for the high quality and best-in-class innovative solutions that we provide. Finally, we will go on the case study. This one is in Qatar for an industrial client. The reference is on the high range in terms of flow for the EcoDisc technology with a treatment capacity of 4,000 cubic meters per day. Here we delivered 12 units, each consisting of 4 blocks of 2-meter diameter discs, which were installed in a light building. This installation is standard, however, in terms of the process line used for the treatment of wastewater for reuse in the irrigation. As we can see on the next slide, there are only 3 steps: pre-treatment, eco-disc with lamella clarification, and a post-treatment for reuse, consisting of a multimedia filter with chlorine injection. And the wastewater from the factory is then treated down to BOD less than 5 and TSS less than 10. This water is then reused in the plant for common usage, such as the watering of the green spaces. Nargis, I will now leave it to you for the wrap-up.
Okay, thanks, Gulvan. Well, so the key message of all of us today is that we are here to support you and advise you. We understand the tough conditions in the Middle East, and we can help you with solutions, expertise, and technologies to overcome those challenges. This was also, as my colleagues have described, our motivation to develop our standardized package solutions. And we thank you all for your attention.